But how many of you, let's say, have a good networking background? Because this talk is mainly about network. Okay, something like half of it. So now, how many of you knows about ipv6? Oh, this is cool. Because I will be able then to skip a couple of slides. So first, a few words about myself. So I'm working for Cisco Systems. I've been there for 12 years now, and doing mainly ipv6 security for 3 to 4 years now. And running ipv6 at home for 6, 7 years, and help a Belgian university to deploy ipv6 on their network. So if you wonder where I'm coming from, okay, obviously my last name is what we say in Belgium, Dutch. You may wonder why my accent is not Dutch. That's because I'm coming really from this town, right? Maybe you have noticed a can. I mean, all the speakers get a nice gift from the organizer, which includes a can of Jupiler. And I'm basically coming from a city which is nearby this brewery there. Anyway, so what I would like to say to you, and again, feel free to challenge me, right? You already know ipv6, you know about security. If you don't like what I say, please voice it, right? I mean, we are there for information exchange and maybe some interaction as well. So the first part will be very fast because most of you knows about ipv6, which is pretty cool. Then we go about shared issue. ipv6 is not that different compared to ipv4, which is the IP protocol that all of us are running for years. So very similar, meaning as well the same vulnerabilities and the same mitigation techniques. Then the next step, we go to specific ipv6 issue. Stuff, vulnerabilities that do not exist in ipv4, so that are new. Not so many of them. Okay, the specific issue. And then a few words about what is the status of all the products, all the firewalls, IPS, in the field of ipv6. Are there as potential, as many features as ipv4, for instance? So, for those of you that do not know ipv6, ipv6 is the next generation of protocol that runs over the internet. Okay, it has been standardized in 97 or something, a very, very old time. And you see the curve there. The blue curve is the number of what we say /8. So the numbers of big networks, right? The first number in an IPv4 address. And how many of them are still available for use? And this is the blue curve, right? And if you look at the left part, this is basically an excerpt, so a zoom on it. And you will see that around 2011, there is no such block anymore. Meaning that we cannot add any more new IPv4 addresses on the network. Okay? Just to show you in another way, which is more interesting. This is a graph done by a colleague of mine, which is called Tony Hein. And it's basically an 16 by 16 matrix, which is 256, which represent each and every /8 prefix in the world. Okay, all the addresses that you are using in IPv4 are somewhere there. In blue, it means that this block is already in use. In green, it's free, available for use, and we are there in January 2000. Top right, if you got good eyes and a good networking background, this is all the multicast address, the class E and the class D. Okay, so we cannot touch them. So now I press a key, and a nice animation. 1 second represents 1 year. And you will see the consumption rate. Okay, we are in 2000. Don't forget 2000. In 2001, there is a big bubble, so there's a slowdown, of course. Okay, if the economy is down, people are investing less and buying less PC and IP address. So let's go. 2001, 2, 3, 4, 5, 6, 7, 8, 9 this year, now, 1st of January next year, 2011. Okay? And it's a call for action, gentlemen. Only 1 block left. Okay, we don't know, of course, this is prediction, right? We don't know exactly when it will be happening. In the green part, this block is even reserved by the IETF. We cannot touch it, right? It's reserved for anything that could happen. So in 2011, we cannot get, let's say I'm oversimplifying here, we cannot get any more IPv4 address. So we need to do something, okay? And as the numbers, the 32 bits of an IPv4 addresses are not enough, we need to put more bits. And this is basically what IPv6 is. So IPv6 is IPv4 with much bigger addresses. Currently, this is the Amsterdam exchange, so where a lot of traffic within Europe is going through between two service providers. And you can see that, that's a graph I've pasted from yesterday. The traffic in Amsterdam is only 1 gig. Not so big, right? Currently, IPv6 is still not very well deployed. But things are changing fast because people start to realize. So they start deploying networks with V6. So it's time as well to understand the security implication of running an IPv6 network. Okay, so listen here. So for you that maybe don't know IPv6, it's not different what we are using in IPv4. Everything which is layer 2, Wi-Fi, Ethernet, for instance, a gentleman who deployed V6 over the Wi-Fi here, has nothing to do with Wi-Fi, right? It works as well. Anything which is above IP, so TCP, UDP, anything, is exactly the same. Okay? Nothing is changed there. All the routing protocols, so SPF and blah blah, are mostly identical. There are only 4 big changes. And the changes are, of course, much bigger addresses. I shall come back on this. So 128 bits compared to 32 bits. So we can put more PCs and more hosts. Okay. Interesting for security, we can have now multiple addresses per host. In IPv4, you have one and only one IPv4 address per host. Okay. If you have multiple, it means that you are a router. On V6, each and every one has got multiple V6 addresses. So my phone here, right, runs Windows Mobile, and by using the Wi-Fi here, it's got V6, it's got 2 addresses already. Okay? Bare minimum. They also done something in V6 to simplify the task of routers. Okay? If you want to do some options in V4, the IPv4 header is varying size. It can be 20 bytes, 24 bytes, 28 bytes, and changing all the time, which is not easy for a router to act upon. So in V6, what they've done, they said the header itself on the cable is fixed length. And if you want to put options, and I shall give you some example, for instance, of fragmentation, of forced source routing, you insert header, okay, between the IPv6 header and the TCP and UDP. If you have ever looked at the presentation where the ipv6 structure is explained, right, or you put IPsec into an IPv4 packet, you remember we put AH, ESP between the IP header and the TCP. That's exactly the same concept. And I shall come back on this later as well. ARP, which is the protocol used in IPv4 to discover the mapping between a MAC address or Ethernet address and an IPv4 address, is disappeared and is replaced now by something called Neighbor Discovery Protocol. So not so many change, right? 4 of them. And a lot of this is security implication. So talking about the addresses, just to give you an idea. So I can be academic, like this one. This is this number. I have no clue how to pronounce it, compared to basically something 4 billion. Okay, the top number is the number of IPv6 addresses. And the bottom number is the number of IPv4 addresses in the world. So now we can do it in another way. And the other way is simply, look at this. That's an atom. Okay? I guess you have not very good eyes, so you need a lens to see the atoms. And let's assume now that each and every atom represents the complete set of IPv4 addresses currently. So the 4 billion. Okay? So we say 4 billion of IPv4 addresses is one atom. To see the numbers of IPv6 addresses, it means 80 tons So 80 tons, what is it? That's a whale. Okay? In this whale, each and every atom represents the complete set of IPv4 addresses. It means simply that we have many, many, many more IPv6 addresses. Okay? Which is the main design goal behind. So, it was basically IPv6 in 6 minutes or something like that. So now, let's look at security issue. And I put some kind of mathematical sets with all the IPv4. You know, I'm very good in physical security. My PC is starting back up now. Great, come on. So on the left-hand side, this is all the IPv4 related vulnerabilities. And on the right-hand side, this is all the IPv6 vulnerabilities. And let's focus now on the shared issue, so the one which are in the middle, belonging both to v4 to v6. And the first thing is reconnaissance. Reconnaissance is network scanning. In v4, it's done in a very easy way. You start at address 1, try 2, try 3, and so on. If you do it over v6, and a reasonable PC with a reasonable bandwidth, it can do it at what we call, say, 10 million packets per second. Do the math. For a single SwiftNet, like scanning the complete Wi-Fi network here, to discover, for instance, the IP addresses of my PC and my phone, it will take you 50,000 years. And guess what? In 50,000 years, first, I will have left this room, right? This room will be most probably in rubbles, and I will be retired for a long time. So, useless. Some naive people, including W. Bush, Chief Security Officer for the Internet, doesn't mean a lot of things, of course, said, okay, with this, we are secure, right? If you cannot find a target, how can you attack somebody? Okay, you need to know the IPv6 address of a target before attacking it. And of course, this is wrong. First, all the important targets are obviously in the DNS. Because if you want to buy something over the internet or make a search, you need to go to the DNS. So now, it's simply replacing trying address 1, 2, 3 by trying name a.example.com, b.example.com, c. and so on. You got the trick, right? Enumerating the DNS. It's a little bit slower, I do agree, but you can find it. And all of us know that within Google you can find a lot of fully qualified domain name. Okay, that's also a very good source for information to find targets. Also, some people, then you will see that I'm both a networking guy and a security person. The addresses in IPv6 are very, very long. Okay, so some people say, let's make the task of the attacker very complex and use basically random bits everywhere. Okay, so 128 random bits, not exactly this, but it's 64, but we don't really care. So nobody can find you. That's true. But now assume the network is down. Okay, the DNS is unreachable because the network is down. And you are the poor guy, and I got a couple of my colleagues that are coming from the technical support from Cisco. They need to connect to a device. So you need to type an address which is very, very long. This 40 hexadecimal digit. Can you remember those addresses from the top of your head? No way. Okay? And it happens in the case of an attack, of course. If you see an alert somewhere in a log, and you need to spend 1 minute or 10 seconds to figure out which machine is this. Is it mine? Is it the server? Yes or no? You lost. Okay? You are the loser, and the winner is the attacker. So you need to get, this is my point of view, it's not shared by everyone, by the way. For important machine, like routers, servers, DNS servers, you need to use easy to remember addresses. Okay, so, because in case of emergency, in case of attack, you need to be clack, 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 like this. And that's what the BruCON team did, because their DNS server over v6 is : 53. Easy to remember, like the UDP port for DNS. Okay, so if you use those kind of addresses, of course you can scan. Okay? But usually servers are well protected, so it's not that big issue. And then, looks like I'm one of the older in the room, but if you ever work with something called XNS and Novel Network years ago, they were also using hexadecimal addresses. And those hexadecimal addresses, you can use characters like A, B, C, D, and F. And you can make fun names like babe, okay, or good coffee babe, or dead beef, or this kind of stuff, right? By using those letters in English. Anyway, so my point here is that it's not because you have so many addresses that you are secure. You can still find targets, okay? And if you think now, it's maybe more reserved for the networking people in the room here, but if you think about it, even the scanning itself, even it finds no target, scanning a so vast amount of addresses is an attack against the router. Because the router, when it receives maybe from North Korea, from China, from Luxembourg, or whatever, a packet that scans on this Wi-Fi network here, the router behind the Wi-Fi access point will try to find your Wi-Fi Ethernet address. So it's sending a probe for each and every packet received from Luxembourg, North Korea, or whatever, is sending a probe trying to discover everyone here. So all the PC, my smartphone and so on, is disturbed, receive data, the bandwidth of the Wi-Fi is used, and more important, memories in the router is used as well. Okay, to keep the state, I need to remember that I've done this. So you can run a DOS from remote on this. There are techniques to solve it, but no time to explain here. So of course now, what is the impact on worms and viruses? Of course, mainly on worms. Most of the worms nowadays, first, you don't see them anymore already. They do not scan so much. Okay? They propagate over email, for instance. And an email address has nothing to do with IPv4 and IPv6. Some of my emails are going over v6, some of my emails are going over v4. I don't care. There's the same IP address. So the worms propagating by email will have the same efficiency over v4 and v6. And for the rest, if there is any worm that want to scan, they will simply use the techniques, okay, as I have described before. Also, as soon as, for instance, they crack or a worm arrive on the PC, it just has to look at the connection table, right, netstat, and sees all the other people connecting to him or him connecting to them. Right, so discover more IPv6 addresses. That's pretty good. So basically, nothing is changing here. This one is less interesting. So that's basically the way we build an IPv6 address. Two parts. The orange one is basically the identifier you use within a LAN or wireless LAN. The left-hand part, the white and the blue, is what identifies a network worldwide. That's what we call the prefix. By default, when IPv6 was designed, the orange part was assumed to be basically your MAC address, so the Ethernet address of your PC. Easy to do, right? So you don't need to provision, you don't need to do DHCP or whatever. You simply take the leading part that is broadcasted over Wi-Fi, over the LAN, and then you take your Ethernet address, and bingo, this is your interface ID. If you wonder about 48 versus 64 bits, we simply had 16-bit predefined constant there. So far, so good. Then some people were concerned. Hey, I'm here. My PC is going, let's say, to Google, right? Nothing against Google, but just an example. So my PC now sends to Google this prefix, so Brussels here, and this MAC address from my PC is there. Then I am going back home. Okay, actually tonight I will be in Terena, where I will get again v6 connectivity in Holland. Now they will see I was sending the prefix of Terena in Amsterdam and the same MAC address of my PC. Okay, then going back to Cisco, my employer, and they will say the prefix from Cisco and the same MAC address. So Google can trace me. He knows that on Friday I was here in Brussels, right? Then after tonight I will be in Terena, and then back in Cisco on Monday. So they can trace me. This is obviously a privacy invasion. Okay, not a big deal, but anyway. So the IETF fixed it in a very simple way. They simply says, hey, rather than using the Ethernet address there, what about using a random number? Okay, so then, and any time I'm changing network, I get a new random number. Okay, even better, on every day, I am getting a new random number. Okay, pretty cool. So in case you wonder, 2 to the power of 64, that's a huge amount of addresses. So the chance of collision of getting 2 PC generating the same random number is pretty poor. And anyway, ipv6 check for this conflict before. It's called duplicate address detection, so it's working fine. So that's pretty cool, isn't it? That's pretty cool indeed when I'm home, when I'm here, and so on. Now, if some of you, and I know a couple of you are indeed, you are managing a network, you do not want your PC changing of addresses every day, because it means that all your audit trail, all your log are useless nowadays. Okay? You cannot find, oh, this ipv6 addresses did a few bad things on my network, whether on purpose or due to misconfiguration. It doesn't really matter. But you cannot find it anymore because it's changed ipv6 addresses. And you can tune this system to change ipv6 addresses every hour, every minute, if you want. Okay, so just beware of it. So use it only, that's what I said in blue there, use it only in the case of when you need it, when you are a consumer, right? Never in the enterprise. ICMP. ICMP, you know it, this is what we use for do ping to test network connectivity. And on this table, I put 2 columns, right? The first one is ICMPv4. We use it mainly for connectivity checks, so ping, pong, and so on. And the rightmost column is for IPv6. And on the rightmost column, we see we are adding stuff to v6. And a few of them, I have no time to go through all of this, is what we call address resolution. This is what replaces ARP. You remember ARP, address resolution protocol in v4? This is how you match an IPv4 address and a MAC address. So it's now it runs over IPv6. So the resolution protocol itself runs over ICMP. So why do I say this to you? That's about firewalls or any IP6 table that you need to put on your Linux machine. So this is the usual security policy that's available for v6. Okay? So it's basically permit a lot of things like echo for connectivity check. Something which is pretty important is packet too big. Again, for the networking people, it's to allow pass-MTU discovery. Exactly the same as in IPv4. Okay, the numbers have changed, but that's all. The semantics is kept unchanged. And this is for transit traffic, so traffic going from one PC to a server behind the firewall. So now, what's new with v6 is that your firewall has to reply to some ICMP. Usually we say firewall never replies to ICMP messages, right? They need to be stealth, kind of transparent. No, we need to change it. For instance, for the line number 3, when I say permit any B133134, this neighbor solicitation, neighbor advertisement, this is everything which has to do how this firewall will discover the internet address of the server of the router which is nearby. So in your IP6 table or in your firewall, you absolutely need to add this line. It was not the case in IPv4, because in IPv4, ARP is not running over IPv4, right? It's a separate protocol. In IPv6, the new ARP is running over v6, so it's all v6 security policies, so we need to allow it. And the same applies for other techniques there. Talking about this neighbor discovery, how does it work? There is something which is pretty cool with v6. It's what we call stateless auto-configuration. It means that when one PC is joining a v6 network, it's sending what we call a RS, a router solicitation. It says, hey, is there any router doing v6 nearby? And if you are lucky, 1 or 2 routers will reply, hey, yes, this is a router advertisement. Yes, there is a router here. This is my address. This is the network address you need to use, and multiple information. So, and do you think anything there is authenticated? No. Okay? Anybody, any PC can send fake router advertisement. Why? To pretend to be the router. Because if you are the router, each and every IPv6 packet that needs to leave the network will go through which PC? Through your PC, because you are the router. So basically you can intercept all the traffic. Okay? This is what you call the rogue array issue. This is currently the biggest attack I've seen on IPv6 network. Okay? And of course there are attack tools for it, coming from our German friend from Van Hooser. Another one. You know most probably about ARP spoofing. Guess what? We can do the same thing in v6. It's no more ARP, as I explained, so it's about neighbor solicitation and neighbor advertisement. So two messages running over ICMP. But again, so I'm basically sending out queries. Hey, who is saving this IPv6 address? And only the node having this IPv6 address reply with his Ethernet address. Very simple protocol. No authentication. Okay? And we know, like ARP spoofing, anybody on the same layer 2 network can pretend to be anybody with any IPv6 address. So it looks like IETF did not learn anything until now. Okay? And there are, of course, attack tools like Parasite6, again from Van Hooser. And there are other vulnerabilities. Okay? No time to go through. For instance, the one is duplicate address detection. That's what I said. When your PC connects to a network, it's basically sending to himself or to itself, hey, is there anybody using my IPv6 address? And of course, if somebody replies, it means that somebody else is using the same address. It's perfectly useful if you're using this random address, okay, to see whether there's a conflict, duplication. So now the attack is, of course, to say nothing is authenticated again. Basically, say each and every time you receive such a packet, is anybody using my address? You reply yes. Okay, then the guy tries another one, another random number. Hey, is anybody using my second address? You reply yes. Third try, is anybody using my third address? Reply yes. Then the PC needs to, it cannot use IPv6 anymore. Nice and wonderful denial of services, right? And again, there are attack tools there for doing it. And if you think about now the mitigation, this is where we come with the bad news. Okay, a lot of techniques were well known in IPv4, like in the case of Cisco, but I guess other vendors doing the same, dynamic app inspection, DHCP snooping, and so on, do not exist yet over v6, right? They will be there next year. The good news, anyway, is that the IETF took the problem very seriously and standardized something called SEND. And two slides are coming on this. It's basically neighbor discovery protocol plus crypto. Well-used crypto. Okay? The issue is that it's not available on Linux, it's not available on Windows, it's not available on macOS, it's only available in basically Cisco routers. Right? So not very useful, basically. Other good news, a lot of things that works purely on layer 2, like again, using the Cisco term for private VLAN, port security to prevent CAN overflow, or IEEE standards like .1x or .1ae, works very well with v6, right? .1x is for authentication, .1ae is for encryption on the fly, on an internet frame. I mean, they don't care about the content, simply, so it works. Few words on secure neighbor discovery now. So secure neighbor discovery is IETF standards that use RSA signatures, that use, of course, RSA key pairs, and that use what we call CGA, cryptographically generated addresses. It means that you do not have the choice of your v6 address anymore. Your v6 address is being computed cryptographically. More explanation. So each and every node, router, smartphone, PC, has got a pair of RSA key, okay, public and private, as you know. It builds basically what you call a CGA, so cryptographic generated addresses, parameter, which takes the public key and the prefix, which is, remember, it is the white and the blue part of the address. Okay, student prefix. He runs a SHA-1, and he gets huge amount of bits. He takes 64 bits, actually 62, of this SHA-1, and it becomes the interface identifier. So what identifies the host within the network, within a LAN? And then, of course, you need to put the student prefix, right, on the left. So you get 64 prefix, 64 bits of SHA-1. I mean, you take only a part of it, and you get the 128 bits. So you do not know your IPv6. You cannot say your IPv6 address to a fun1 or to ::1 or ::53 or whatever, right? It derives from your public key. And then, of course, it's not enough. You need to do send. This is what send is doing. It's basically using then your private key to sign each and every neighbor discovery message. Okay? So now the recipient, when you claim to get an IPv6 address, to claim to have this CGA, okay, you receive the packets coming from this address with the public key, so I can redo quickly as the recipient the same map, and I can check, yes, this IPv6 address has been computed based on this public key, and then I use the public key to verify the signature of the mapping between the internet address and the IPv6 address. Done. No need for certificates there, right? It's just a proof of possession, of ownership of a v6 address. It does not prove you that you have the right to use this v6 address. It just proves you that the mapping between the internet address and the v6 address is this, right? No certificate means there is no CA. We have no authorization there, right? It's just a secure mapping, that's all. Which is already pretty useful, right? With this, app spoofing, I mean, for v6, does not work anymore. So seeing the share between v4 and v6, a lot of things is identical. Sniffing is the same. When Justin was talking about SQL injection, of course, SQL injection over HTTP, over IPv4, or over IPv6 is exactly the same. Okay? The only attacks I have personally seen on my servers were brute force attack against SSH over v6. I'm pretty sure that the attacker has no clue that he wanted to go over v6 to my PC or to my server. Right? He was wanted to attack ving.org, and he was bombarding me with a brute force attack over v6, but he doesn't care. Flooding, this is of course all the denial of services you can do as well over v6. One issue which is also shared are bugs. Okay? There are bugs in v4, there are bugs in v6 implementation. So I put there, we need to refresh, but basically each and every operating system, okay, whether it's a BSD derivative, Linux, Microsoft, Apple, everyone got bugs and still having bugs. I put Cisco there. iOS is basically the operating system of our routers, but be confident other vendors are doing the same problem here. Okay, so bugs. The good news, IPv6 is more and more deployed, so bugs are found and fixed. Okay. Not the bad news or good news, it depends on which side you are. There are multiple tools for it. And SCAPI, which I use a lot to generate packets or attacks packets to see how things behave, is now working very well with IPv6. So it's even incorporated now. Okay, what's the first part? Basically, the good old tricks, app spoofing, reconnaissance, coming from v4, applicable to v6 as well. So now, let's move to the right part, maybe the more interesting one, specific IPv6 issue. And the first one is that a myth, I really consider it a myth. People say, because IPv6 and IPsec are tightly linked together. Okay? It's stated into the NRC, or a standard from the IETF, if you pretend to be an IPv6 node, you need to have IPsec. You need to have the implementation of IPsec. You do not have to implement, to use it and to configure it. Okay? Vastly different. So you can perfectly be an IPv6 node with the IPsec code and not use it. So it's legitimate. Some people again says, hey, great, every node IPv6 is using IPsec, so first it's not true, okay, as we have seen. And if everyone is using IPsec, then we are safe. I mean, if you think twice, it's not the case, of course. If you want to use IPsec in a secure way, you need to get strong authentication. Can we scale any PKI to, remember the big numbers of nodes I've put with all the addresses? No way. Okay. And moreover, if you do this, it means if everything is encrypted, then everything which is in the middle, intrusion prevention system, firewall, sniffers, lawful intercept, or whatever tools that is a good guy you want to use to protect your network are blinded, okay, because everything is encrypted. So I don't personally consider that using IPsec everywhere will solve all the problem. So of course, use IPsec when it's needed, right? Don't take me wrong, I love IPsec, but don't use it everywhere. Also, one of the biggest challenge, of course, is that IPv4 and IPv6 protocols are not, you cannot interoperate easily between each other. Okay, you cannot send an IPv4 packet to an IPv6 without any magic inside, in the middle. This is all we call transition techniques. And it won't know while we won't say on the 1st of January 2011, hey, please, to say to my father, throw away your Windows 95 and replace it by Windows Vista that support, for instance, v6. There is no red flag day when you declare, yes, v6 is now. No. Okay? So you need to get a gradation, a coexistence. And there are multiple techniques. One, which is, by the way, my favorite one, is dual stack. Dual stack because you get a TCP IP stack for v4 and a TCP IP stack for v6. Dual stack is the name. So your PC runs two protocols. Okay? And I guess by looking at the PC here, each and every PC in this room is dual stack. Okay? So it means now, if you think about the OS security, you need to think twice indeed. Because you can be attacked not only about over IPv4, but also about IPv6. Meaning, for instance, if you are running any Linux, which is running v6 natively as well, so enabled by default, not only you need to configure IP tables, but also the v6 version of IP tables, which is IP6 tables. If you forget about it, you get a big issue. Okay? Still easy to understand for you. Now think about your little sister or your girlfriend or whatever, which is running a laptop with Vista on it. Right? It needs to be protected by both as well. And as soon as you don't apply the same security policy for packets coming over v4 or packets coming to v6, you are into trouble. Because the potential attacker will attack you on the weakest link, what we call fate sharing, right? You are as strong as the weakest TCP IP stack. And an example that I really love with a yellow smile here, this is basically what a product from Cisco, which is behaving badly, which is the IPsec client. Okay, this is used basically to connect a PC or a Mac from this place, for instance, safely to your corporate network. And it can work in what we call no-split tunneling. The red stuff is the IPsec tunnel. When you apply no-split tunneling, it means that all, when you read the paper, all IP packets needs to go from the PC into the tunnel to corporate, where basically you get firewall and IPS. The goal is that nobody can hack or control this PC by using any kind of botnet or command and control channel and jump over v4 and jump into the tunnel to attack your network. Okay? This is no split tunneling. Great. But they say IP packets, meaning that's IPv4 packets only. So now if an attacker sends you an attack over v6, this packet will be received by the PC, even if there is no split tunneling. Right? Any clear text IPv4 packets are dropped with this. Any IPv6 packets are accepted. Okay? So if the command and control channel of a botnet is over v6, and they are already, it goes through. Okay? Really, really bad. If you know about it, it's okay. Right? But a lot of people don't know. And for instance, my biggest problem with IPv6 and security is this one. You are running a host like Vista, okay, or Mac or Linux or anything, and you know that you need to use IP tables. You need to configure your IPv4 security, but you have no clue about v6, but it's enabled by default. But you say, hey, I don't care, right? My network at home, at the office, doesn't run v6, so I'm safe. What you say? You're safe. No way. Okay? If any of your PC is associated to serve host space IPv6, which is the IPv6 enabled wireless LAN, your PC, right, was sending for 1 year, 2 years router solicitation. Hey, is there any v6 router nearby? And he was trying every minute for a couple of years. This morning it started. Somebody replied to it. Okay? A router from Megacom basically replied, yes, there is a v6 router. And then your PC immediately enabled v6. Okay? And its v6 addresses can be reached worldwide, anywhere from the world. Okay? You are a security person. It's okay, no problem, no big deal. The same thing can happen for the people. The same thing can happen as well in an office, for instance, where a Trojan is simply sending this router advertisement. And then each and every PC on the same subnet believes there is v6, but it's basically the Trojan which is doing it. And then all the v6 traffic is sent to the Trojan, can be intercepted, modified, and so on. And there are more and more v6 traffics coming. So that's basically a real problem. And that's what I say to a lot of security people. Please, even if you don't deploy v6, it's time to think about it. Really time. Other point with the transition, sorry. So not everyone can do dual stack, because dual stack is possible here when you get both v4 connectivity and v6 connectivity. But what if you are in another place where you have only v4, like at home? Then what you do, use tunnels, like ipv6 tunnels, but without crypto. It's basically you encapsulate, right? You have two islands here. So all the traffic going from the rightmost island to the leftmost islands, which is only v6, they need to go, for instance, over the internet, which is mainly IPv4 now, and even if most of it is v6 or enabled. Then v6 packets arrive at the router and they encapsulate it into an IPv4 packet, like an envelope, traverse the IPv4 internet, arrive at the other router, where the router removes and opens the envelope, extract the v6 packets, and send the v6 packets to the left. Cool. Okay, it's working fine. If you think about the networking aspect, real fine. So now, the bad guy is there. He can simply do the same, okay? Put a fake IPv6 packet into an IPv4 envelope, spoofing the source address, and the destination is the left router. So the left router receives this kind of envelope, encapsulation, remove the IPv4 envelope, get the IPv6 packet, which is forged, and send it to the destination. Okay? So it can at least inject data. Because all those tunnels, and there are many of them, have no encryption at all. So no confidentiality, no integrity, no authentication at all. Okay? And of course you can sniff as well. Another one which is very interesting is Teredo. Alors, Teredo, what is it? Teredo, if you think about it, that's the beast which is there. Right? I mean, first time I've seen this picture, you really wonder what's this. That's a worm. Actually, that's a kind of a muscles or whatever. That's a shell. The white part is the shell part, right? But the main part of the body is outside of the shell. Very strange beast, but that's it. What it does, it's eating wood, and it's a sea worm, right? A small beast. Where do you find wood? In the sea, mainly in the hull of the good old ships, right? So it was drilling holes into the hull. So basically sailors doesn't like it. So now, one issue of the tunnels with v6 is that they are always encapsulated in what you call protocol 41. So now, if you have ever deployed IPsec, at the very beginning, I mean around 2000, IPsec was unable to traverse a NAT device because NAT only worked for TCP or UDP, and IPsec was neither UDP nor TCP, so it wasn't going through. They had to extend IPsec to encapsulate it into UDP, which could be transmitted by NAT. Same thing here. All the v6 tunnels are running natively over v4. So no UDP, no TCP, so the NAT can do nothing with it, so they drop. So Microsoft invented something which is called Teredo, right? Microsoft it's a joke of mine. But basically it says all those tunnels I will encapsulate it into UDP. Okay, so I can traverse NAT. So they were basically drilling holes through NAT. So if you think about it now, this is a usual, let's say, banking environment or whatever, where at the bottom you have the IPv4 intranet, and on the top you have the IPv4 internet and the IPv6 internet. You put a firewall in the middle, that basically says two things. My internal user cannot go to BitTorrent because I assume to work, and the people on the right, the bad guy, is not able to penetrate my network. So now, the PC installer software, which is mostly, I mean, a couple of us are using to download, of course, Linux and BSD, right? Nothing else. MicroTorrent. MicroTorrent, since last summer, is ipv6 enabled. Last summer, 2008, so it's in two summer now. And it's using this Teredo. So the guy, maybe he's installed MicroTorrent at home to do it at home. When he was trying to do MicroTorrent at the office, it was never working. Now it starts working because it's using Teredo, right? So it's going through the NAT, okay, to do BitTorrent. Not very good for the company. But even worse, as soon as there is a single opening for Teredo in the firewall or the NAT, then anybody on the internet, anybody, right, can use this hole to attack the PC inside, which can be used as a stepping stone. Okay, Microsoft has done a few things to secure it, but it's still a threat. And this is real, right? If you install, for instance, MicroTorrent since summer 2008 on an XP machine, it says, do you want to install V6? Because on XP, V6 is not enabled by default. On Vista, it doesn't even ask the question because it's already installed. Okay, and on the left-hand side, this is just to show you that there are multiple V6 peer. People do it, of course, to escape policy, copyright people, right? They don't, because all those copyright people that check what is downloaded, they can only do it for V4. If your download is over V6, you are not seen, right? You're invisible for them. Another transition techniques, it's not really transition to V6. It's mainly a way to address the exhaustion issue, right? In 2011, we have no more IPv4 address. So basically people start thinking, right, I don't want to do V6 immediately because blah, 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 blah. I prefer to run an IPv4 network for a while. And some service provider will do this. So on the left-hand part, this is your home, right, with all your PC and your small router, what is a D-Link, Linksys, or whatever, which is doing that. Okay, to, I don't know, to Telenet or Skynet or whatever, which are Belgian ISP or... Then the ISP will do in its core also a NAT function. Okay, you will be doing dual NAT there. This is called carrier grade NAT because it's a very big box. I mean, my employer hoped to sell them. It's about €1 million piece, so great for us. But then, because you will be able to share one IP address by multiple homes, okay, and each of these homes is sharing this already shared address by multiple PC. Then you have a couple of issues. I will focus mainly on the bottom one. So you share an IPv4 address by multiple subscriber. Okay? So now, how can the police, for instance, do something maybe we don't like it, LI, lawful intercept? Okay? How can the police can only intercept on our end in our countries, right? So no problem here. Intercept the conversation of a potential terrorist without taping also any good people, good citizen, good subscriber in the same town, because all of them have got the same IP address. Challenging. If you want to keep the logs, right, to see, oh, this UDP port of this address was used at that point of time by this subscriber, you need to keep one line of log for each and every TCP connection from your subscriber. Okay, so invest in hard disk manufacturer. There's the time. Even worse now, we all know about the blacklist. Okay, when you say the reputation of this IPv4 address is bad. Okay, because this guy is sending spam, so he must be under control of botnet. So now what happened if in one town, which is sharing the same, assume that all the customers, going back on one slide, all the customers of the same town, like Brussels, which is a big one, share the same IP address by this device, right? All the people in Brussels having the same IP address. So now, what do you have? You end up with something like one bad guy in Brussels, and I'm pretty sure there are more than one, is enough to put the reputation of this IPv4 address down, and then every users in Brussels will be denied access in some website. Okay, sharing the fate, which is pretty bad. Okay, just to finish quickly. So it was about the threat. There are many more. I don't have time in 1 hour to go through. On the other hand, right, people are aware of it, so all your service provider, all your vendors can do a lot of things there, mainly by enforcing a security policy. And when I was talking about, this extension headers chain, just a few things about how an ACL work, whether it's in a router, in a firewall, or IP6 table, or whatever. So the packets look something like this. You have the IPv6 header, and you see in green the TCP. This is where you want usually to say permit 22 and block, 21. In the middle, there are multiple extension headers, 3 here. So it means that now your ACL, or your IP6 table entries, needs to be able to pass the chain. Okay? After the IPv6 header, that's hop by hop. Hop by hop, this is so many bytes, so I need to go to the next one. Oh, routing, this is so many bytes, so I need to go to this one. Okay? You need to pass this chain. It's doable. Okay? But what happens if, at some point of time, because when do I stop? Okay, when I recognize TCP or UDP. Okay? But what if the layer 4 is a new TCP that I am not aware of? Do I need to continue? Is it the last one? I have no clue. And the other one is that what happens if, same thing, right? A new extension headers. Currently there are about 5 of them. What if the ITF invented a 6th one? And then your old routers are only able to pass the 5 first one. What is that? What is he doing when he receives the 6th extension header, the new one? Right? So, couple of question mark here. You can apply ACL, again, IP6 table, just to give you an idea. This is Cisco devices, right? So, firewalls and so on work since 2005 to give you an idea. So, it's working, the same thing for most of the vendor. We've got what you say firewall service module. This is basically a hardware network firewall. Right, doing very fast gigabits in v4, but only doing 80 megabits, so much less, 100 less for v6. So you need to replace it, right? As you have IPS and blah, blah, blah. So there are a few things there. If you want to do secure connectivity, right? For instance, from here where I got v6, I want to go home safely over v6. There are multiple ways of doing it. One way is, for instance, between the 2 routers. In orange, this is this infamous v6 in v4 tunnel. We've seen it's by default not encrypted, so anybody can sniff it and inject data. This tunnel is basically IPv4 packet, okay, to traverse the internet. And how many solutions, how many vendors can encrypt IPv4 packets over the internet? Many of them. Okay, so you simply do this. You put all your v6 packets in v4, and then you use IPsec over v4. Done. Okay. A new trend in VPN is to use SSL for the tunnel, and of course within this transport, within SSL, right, you can put IPv4 and IPv6, so it's working fine as well. No problem there. So regarding the set of tools that you have to mitigate attacks, we are in pretty good shape. Okay? The only thing is really about education. And if I go through best common practices, the first one, I won't go through all of them, right? This is mainly for your reference later. The first one is train yourself. Okay? It's a little bit too late already. v6 is a threat maybe for your network. So now you need to understand the threat. And as soon as you understand it, it's no more a threat, right? Education, knowledge is always key as usual. You have a long list of things. You can do it and you can do it. So if we want to go to some conclusion, half an hour we spent explaining that things like ICMP, ARP spoofing, reconnaissance are mostly unchanged in v4. Okay, so you need to be aware of it. So what you already know in v4 is still okay for v6. Lack of operational experience, lack of security officer experience in v6 is real threat. Educate yourself. It's fun, by the way, as well. Okay, security enforcement is possible. You have IPS firewall, whether it's host-based, which is free, or from a vendor, it's there, right, from a long time. Leverage IPv6, IPsec if you need it. Don't use it blindly, simply because it becomes you blind. Last point, if you are running a network, that's a test I'm telling to some people I'm meeting, right, once or twice a week. Please do this in your network and come back to me if it's not working for you. because IPv6 is already in your network. Okay, a couple of ways, so you can sniff or use netflow record, and you look for this specific kind of traffic. If you have seen this traffic or DNS resolution for a host called ISATAP, which is another tunnel, it means that you have PC, Mac, Linux in your network that are trying very hard to get IPv6 connectivity. Right? As soon as an hacker or a Trojan arrives in your network and pretends to answer this, it will switch to v6 and start using it. Okay, then it will be not really good for you. So I would like to say thank you to Mark, which is here. I have no clue where the other one are. I would really love to see you, gentlemen from Belgium, because you enable v6 on this wireless. And honestly, you should try it, right? You have 2 days for trying it. First, enable, of course, IP6 table, change to this SSID, and look what's happening there. Okay? That's an opportunity for you to understand what is it to run an IPv6 network. And just as a small hint for what's coming, so IPv6 is really better with a Belgian beer, right? So don't try Dutch beer or whatever, right? Only Belgian beer, way better. Thank you. Anyway, I wrote a book here on IPv6 security together with a friend of mine. So it's about 400 pages, so it's impossible for me to summarize it here, right? So read it. I got the blog as well on this IPv6 security. Okay. I guess we still have time, a few minutes for questions.
5 minutes at least.
5 minutes. So first, thank you for listening. And any questions?
No one?
They are angry. They want to get some lunch. There is somebody there.
About the device that you said that your company would sell that allows to use one IP v4 versus others, that would pretty much kill a lot of the companies that's supposed to do anti-spam, no? Because it would be almost impossible for them to analyze what's going on.
Yeah, I fully agree. So we'll try to come back on this slide. To come, it's too late. So when we were sharing an IPv4 addresses among 1,000 different subscribers, of course, people that rely to do anti-spam, but it's not only anti-spam, right? A lot of things where you put a reputation associated to an IPv4 address, forget about it. Okay. So my company, as you know, is offering one of those products. So we are trying to scratch our head how we can fight this, but it's a real concern of us. Yeah, and I'm afraid that technology is just there, right? So we push it to the maximum. Yeah, real problem.
Anybody else?
What can you recommend large companies do in order to try to detect a flooding attack?
Flooding of a v6 packet?
Yeah.
So it's relatively easy because if the link, I guess the attack is coming from the internet, right? The OS coming from the internet. If your link through your ISP is not IPv6 enabled, then those packets will be stopped at your service provider. Okay? So you have no IPv6 connectivity to the world, you are not a target of an IPv6 denial of service. Great. Now, if indeed you are an IPv6 user and you have a contract with your ISP that tells you, yes, please send IPv6 traffic to me, if you are flooded, the good old way of detecting the attacks are still there, which is basically line utilization, okay, how many percentage of my bandwidth is used, as well as counting the numbers of packets per second through techniques like NetFlow. So again, in this place, we are lucky. There's the same as IPv4, so you can apply the same techniques. So remote triggered black hole and blah, blah, thousands of techniques can apply as well for v6.
Thank you. This concludes the presentation about the IPv6. Now there is a 60-minute lunch break, but before you leave, I would like to say that downstairs at the reception, there is a lost and found space, and somebody has lost their laptop cover. So if he misses it, you can get it downstairs at the reception. Thank you.
Thank you.